Let's introduce the concept of absolute convergence, or we'll be saying that a series might be absolutely convergent. And the definition is that a series is absolutely convergent if when you take term by term absolute values and add those up, then the series converges. So for example, here we have an alternating p series with p equals 2. And if we take the absolute values of each term, that basically just throws away this -1 to the n, right? And so we just get the sum of 1 over n squared. Is that sum convergent? Yes, it is, because p equals 2 with the p series. So this is convergent. So what can we say about, so we'll say convergent, p equals 2. So what can we say about this series? It is absolutely convergent because when we take absolute values, we get a convergent sequence, a convergent series. Let's think about another quick example. Is the alternating harmonic absolutely convergent? Well, the alternating harmonic is convergent, but the sum of the absolute value of -1 to the n minus 1 is 1 over n is the sum of 1 over n, which diverges. So when you take absolute values, you get something that's not convergent, you get a sum that's not convergent, so the alternating harmonic is not absolutely convergent. So it turns out there's a word for things like that. First, let's say if a series is absolutely convergent, if it's convergent when everything you're adding up is positive, then when some of the things are allowed to be negative, you won't get quite as big of a number, but you're in no danger of running away to infinity. Even if they were all suddenly negative, then you would just get the negative version of whatever positive sum you've just gotten. So if a series is absolutely convergent, then it is convergent regardless of whether there's positive or negative signs. And if we have a series that converges when it has the positive and negative signs, but it's not absolutely convergent, we call that conditionally convergent. So it's conditional on having whatever negative signs it has that make it converge. But when you take them away, it's no longer convergent. It doesn't have to be specifically alternating. It could have just a haphazard pattern of pluses, minuses, or it could be alternating. So based on all these ideas of convergent, divergent, absolutely convergent, conditionally convergent, it might be nice to make a Venn diagram. So we don't have to put any series in it like 1 over n or whatever, but just how do we split these up? Where do we put absolutely convergent? Where do we put conditionally convergent? So go ahead and make an appropriate Venn diagram. I've given you kind of the outline here. Well, maybe pause the video and come back. If a series is absolutely convergent, then it is convergent, which means absolute convergence is a subset of convergence. And we said anything that's not absolutely convergent but is convergent, which would be outside the subset of absolutely convergent, is conditionally convergent. So this convergent category is basically split into 2 parts with nothing else in it. I almost said halves, but it's hard to say like half of convergent series are conditionally convergent. There's no way to put a number estimate on it, like 50% or whatever. So we could say this whole convergent category is broken into 2 pieces. One is conditionally, and the other is absolutely. So a series is either divergent, or it's conditionally convergent, or it's absolutely convergent. Either of those count as convergent, but for the conditionals, if you put absolute values on it, then it ends up divergent.